Okay, page 6, graphing sine. So here is the sine curve already graphed for you. You could always make a table, but we're really going to focus on these main 5 dots that you see here. So notice this is the parent graph, right? This is the one where we haven't done any transformations to it. So notice the first dot, which I'm going to call the beginning, is on the x-axis, which I'm going to make green real quick. It's kind of a light green. And it's at 0, 0. Then we only graph one period of sine. So a hump up and a hump down, or sometimes there's a down hump first and then a hump up, or hill and a valley, however you want to think about it. And then it just keeps repeating over and over again. So we're not going to waste our time repeating it over and over again. We're just going to graph one period. So the beginning and then the end for the parent graph, when there's no transformations, is at 2 pi, and it's also on the green line. Now we're just going to cut this up. So if you see my 2 big red dots, right in the middle of those, I'm going to call that the middle, is also on the green line. So if you know beginning and end, you can easily cut things in half. You could always add and divide by 2 to cut things in half, right? Then you know the middle line and it lines up. All 3 of those dots are on that green line. That green line is called the midline. Then if I look at piece by piece, between the middle and the beginning, in the middle of that section, it does the amplitude. This distance from here to here is A. Then between the other half, right, between middle and end, right in the middle of that, it does opposite the amplitude. So this point is opposite the amplitude. So it's still a distance of A, but it went downwards, A for amplitude. So down here it says the amplitude of sine is 1 when there's been no transformations. So we're going to find the beginning and the end, we're going to cut it in half, and then we're going to cut those in half again. So to graph sine x, it's literally just the same thing up there. I would draw a green midline at 0 because there's been no transformations. We're going to talk about transformations in a minute. And then my first point, because there's been no transformations, is at 0 on the midline. My end point is at 2 pi on the midline. I can see the middle of that is pi on the midline. The middle of the first piece, up 1. Middle of the second piece, down 1. And it's a wave. It's supposed to be curvy, not pointy, and it does continue on forever, but we're just going to graph one period of it. Notice up above, the period of regular sine is 2 pi. When there's been no transformations, the period is 2 pi. What period means is it's the distance from beginning to end. So to get a full wave function from 0 to 2 pi, that distance is 2 pi. That's just a mess, but you get the idea. The distance to fulfill a full cycle. So here is all the stuff we can do to transform the sine function. So the A value is the amplitude, but the answer to amplitude is never negative. But A is amplitude, half the vertical distance from high to low. B is going to help me find the period. So that B value, 2 pi divided by B, is the period. So we'll have to do some math. And then your H and K are just like before. So H, opposite H, is going to give you the horizontal shift. And then K, the constant. Oh, I wanted to make that one green. Sorry, it doesn't matter. If you're not highlighting with me, it doesn't matter. But I want K to be green because that's what color I made the midline. K is the midline, and H is your horizontal shift. So it's a lot easier if we talk about this in context. So let's go to our first example. Okay, graph and state the period. Okay, so I'm going to try to highlight in the same colors. I might have to go back. So yellow for A. B is an imaginary 1. H there's a plus pi in the parentheses, and k is the -2. So here's some answer blanks we need to fill out. So I know the graph is on the top, but we need to answer a bunch of stuff before we ever even consider doing the graph. Amplitude. Is there a vertical reflection? And that's just a yes/no question. We need to know the period. We need to know the phase shift. Let's just stay over here. We need to know the vertical shift. Sorry, something happened. Catch up with my answer blanks if your video did something weird. You haven't missed any math yet. And then we need to know beginning and end. I might fill in some more stuff in a minute. So here we go. Let's match up our colors. A is going to give you the amplitude, but amplitude is never negative. Are you listening? Amplitude is never negative. Amplitude is a height, and heights are never negative. So the amplitude for this is 3. Because it's negative, yes, there's a vertical reflection. Period is always 2 pi divided by that b value, which was pink. Our b value is an imaginary 1, and you can expect that a lot in this class. So our period's 2 pi. Phase shift, looking in your parentheses, so this was our blue one. Phase is like horizontal. So it says plus pi, so you're going to go opposite. You're going to go left pi. Phase shift always has a direction, a left or right attached to it. Same with vertical shift. And these work just like parabolas and everything else we've done. Down 2. So my beginning matches my phase, but instead of using the word left, it's going to be negative pi. So write a note to yourself. It's the same thing as phase, but instead of the word left, we use negative. To get the end, you have to do math. The end is beginning plus period. So the beginning of mine is negative pi, and my period is 2 pi. It's just like x. Treat it, so it's negative x plus 2x, you get x, or pi. So it's going to begin at negative pi, and it's going to end at pi. So here's what we do. We draw in our new midline. Our midline is down 2. This is an imaginary line, that's why I'm making it dotted. It's not an asymptote. It's just to help me get the graph. So I draw my new midline. Now remember, for sine, there are 3 points on the midline. So you should be able to get 3 points really easily for sine. It begins at negative pi. Negative pi is on the green line, on the midline. It ends at pi. Pi is on the green line, on the midline. You can easily see the middle. For sine, the middle is on the midline. Now we need to take a break. So it does have a vertical reflection. So what color did I make it randomly? Yellow and pink. That's probably not a good idea. So I don't know. Purple. This half of my graph, I can see the middle of that half. The middle tick mark, that's just a tick mark, would be at negative pi over 2. But this has a vertical reflection. So sine normally goes up first. But since this has a vertical reflection, we're going to go down, and we're going to go down 3 because the amplitude's 3. From the green line, you go down 3. So if it went down first, that means it has to go up next. So find the middle of that section and go up 3 from your green line. This is our sine curve, 1 period of our sine curve. Okay, let's try the next one. All those answer blanks. Amplitude. Vertical reflection, which is a yes/no. Period. Phase. Vertical. So let's color code some stuff. we have 2. That's going to help us with our amplitude. Again, we have an imaginary 1 in front of that parentheses. That'll help me with my period. It's not the answer, but it'll help me. Plus pi over 2 in the parentheses will help me with phase. And plus 1 at the end will help me with vertical. So amplitude. The A value is 2, which is good because amplitude is always positive. But because the A value is positive, there is no vertical reflection. Period is 2 pi divided by that imaginary 1, which is 2 pi. Phase, it says plus pi over 2. You all know that does the opposite because it's in parentheses. So that's actually going to go left. And I'm fine with you drawing an arrow, but in Schoology there's no arrow. Left pi over 2. Always give me a direction. Plus 1 is going to move it up 1. So my beginning. It is the phase, but with math instead of words, right? Instead of left, it's negative pi over 2. End, beginning plus period. Beginning plus period. You need to make it over 1 and make a common denominator. So times 2 on top, times 2 on the bottom. Just add or subtract the tops. 3 pi over 2. So my vertical shift first, plus 1, up 1. That's a really light color, sorry. Up 1. That's my midline. 3 of the dots are going to be on that green line. Begin, negative pi over 2, on the green line. End, 3 pi over 2, on the green line. Find the middle of those, on the green line. Now we need to slow down a little. My first half does the vertical reflection and the amplitude. There's no vertical reflection, so I go up 2, right in the middle of my first half of this graph. My second half does the opposite, from the green line down 2. Remember, it's all based on the green line. Once you get your green line in, you don't even need the x-axis anymore, except for the numbers on it. But this is my sine curve. Okay. C. So here's the thing about C. It's already been simplified, but don't be surprised in class if I give it to you like this. So now we have a B value. So what you want to be noticing on this problem is that it's 3x. That's what makes it different from all the other problems. And to get it in graphing form before you start doing anything with it, you factor that 3 out, divide by 3, and divide by 3, and that's where this equation came from. But I would not be surprised if you had to factor that 3 out on your own. So it's just GCF factoring. If you're struggling with GCF factoring, come in and get some help. So same answer blanks. Amplitude. I'm going to start shortening them now. Period. Phase. Vertical. And reflection. Vertical, I should say. Yes or no? Okay. So looking at it in graphing form, we've got our A value. Now we have a B value. We have minus h in the parentheses, and our phase as the constant. So the amplitude, the A value is positive 1/2. That means the amplitude is 1/2 and there is no vertical reflection because it's positive. The period is 2 pi over B. Now I'm dividing by 3. This is the first time we've had a period that wasn't 2 pi. So 2 pi over 3, just leave it like that. The phase says minus pi. We know that's opposite, so it's going to go right pi. And the vertical says plus 1, so that's going to go up 1. So my beginning, take your phase and put it in numbers, positive pi. And my end, beginning plus period. So common denominator. Add the tops. Okay, and we also didn't give you any axes. So x-axis can go pretty much in the middle. Pretty much in the middle is going to work. My y-axis, everything's to the right. So see how it's beginning at pi? There's not going to be anything on the negative side, so I should put my y-axis like right here so that I have enough space, try to make it straight, to draw my graph to the right. You get the idea. Now, your scale is determined by your common denominator. So see how it ends at 5 pi over 3? That tells me I want to count by threes. So I want my denominator to be 3. So let's go 2 tick marks, and that's pi over 3. 2 more tick marks, 2 pi over 3. 2 more tick marks, 3 pi over 3. I'm just adding a pi over 3 every time. 4 pi over 3, 5 pi over 3, 6 pi over 3, but I'm already past what I need, right? Because I only need to go to 5 pi over 3. Okay, so I scaled my axes. The y-axis always counts by ones. So vertical shift, up 1. Draw your new midline. Beginning is on the green line. Beginning is pi. You have to be able to know that that's 3 pi over 3, right? 3 pi over 3 is pi on the green line. End, 5 pi over 3. 5 pi over 3 on the green line. The middle of that is 4 pi over 3 on the green line. Middle of those, the amplitude is positive 1/2, so up half a unit for the first one and down half a unit for the second. No vertical reflection means it goes up first and then down. And you can see that this is really, really smushed. This has a horizontal compression. We're not going to test you on that. But that 3 in front of the x made the graph really, really smushed as far as left and right. Horizontally compressed is what we would say. So we'll practice this more in class, and hopefully this is helping you graph sine. Hope you're doing well.